Jai Hind, welcome to the course Network Analysis and Synthesis, and today we are going to discuss about the duality of this course. So, learning objectives of these topics are what is duality, then we will discuss what are the importances of duality, why we need to study the duality. Then what are the graphical procedures to draw the dual of a network? If a network is given and you are required to draw the dual, so what are the procedures, how we will draw it, that we will discuss under this. Then in the last we will discuss what are the limitations for the duality in a network. So the duality is defined from the term dual, which is a pair of two. So suppose two networks are given, N1 and N2, and you are required to find some duality among these two networks. So how will define? So network point of view, the two networks are said to be dual to each other if the mesh equations of network N1 are node equations of network N2. So look at this circuit diagram. This is a circuit, very simple circuit diagram consisting RLC with energy source voltage, and they are connected in series. So if you apply the Kirchhoff's voltage law, we can get this equations. Okay. Then there is another network where the RL and C are connected in parallel, and we have written this equations. So for series RLC network, we have applied the Kirchhoff's voltage law and write the equations. For the parallel RLC circuit, we apply the Kirchhoff's current law and we have to write the equations. So look at these two equations. These equations specify identical mathematical operations. The only difference is being the later. Here we have the voltage, in the place of here we have the current. Then in place of resistor we have the conductor, then the inductor, then capacitor, and so on. So if we get the solution of one network, say N1, we can get the solution of the other one. So this is the beauty or the importance of the dual network. When the network is very complex, it is very difficult to apply the Kirchhoff's voltage law. So what we do is just draw the dual of that network and apply the Kirchhoff's current law. So and solution will be the same. Then this is the definition of electrical network, duality of the electrical network. By the same way, we have the definition in the case of the graph theory. So from the graph theory point of view, we have the definition of duality. So two graphs G1 and G2 are dual to dual of each other if the cut set matrix of G1 corresponds to tie set matrix of G2. So there are two graphs are given, and we take a tree, then we define the tweaks and links and find the fundamental cut set matrix of one graph. By the same way, we select a tree. Remember the suppose in the graph G1, 1, 2, 3 are tweaks and the remaining branches are links. So in the dual network, 1, 2, 3 will be the links and remaining branches will be the tree. And we draw the tree, then take the cut set and find the fundamental cut set matrix. If both the tie set matrix of G1 and cut set matrix of G2 are same, then these two graphs G1 and G2 are said to be dual to each other. So this is the definition of duality from graph theory point of view. There are some dual relationship. We can see the duality, the dual of the current is voltage, then the resistance, conductance, inductance, capacitance, impedance, admittance, reactance and susceptance, branch current, branch voltage, mesh or loop, node or node pair, mesh current or loop current, node voltage and node pair voltage. So these are the variables related to your network. network. Remaining the links are defined in case of the graph theory. Basically the branches of core tree are known as links. Then we have the link current, then tree branch current, tie set. So what is the dual of link? The dual of the link is tree branch, which is known as twig. Then link current, tree branch voltage, that is the twig voltage. Then tree branch current, link voltage current, the twig current, link voltage, tie set, cut set, short circuit, open circuit, parallel, series. Then we can draw some more dual relationships. Suppose Thevenin's theorem, the dual of the Thevenin's theorem and the Norton's theorem. Okay. So this way these are the some dual relationship, some variables. Now the most important thing is if the network is given and you are required to draw the dual of that network. So how we will do it? So there are some rules or procedures we have to follow to draw the dual of a network. So what are those? First, identify the message in the planar network. The network must be planar. If you want to draw the dual, that network must be planar. So first and foremost, identify the message. What are the message? Message are nothing but they are the independent loops. And what is loop? Loop is a closed circuit. So first and foremost, identify the message in a planar network. Then second, inside each mesh place a node and number them for all the meshes. Suppose in the previous circuit, simple series RL circuit we have seen, there is only one mesh. So there is one loop, or we can say the one, and we mark one that mesh. Okay. Place a reference node outside of the network, say O. Then draw a line between two nodes of the original network, traversing only one element at a time. So between the main node and the reference node, connect a element, traverse a element only one at a time. This is the procedure. Then draw the dual between the same. Suppose a series RLC circuit, these components are in series. So in the dual, they will be in the parallel. So if you want to draw the dual of the resistor, that will be the conductance. The resistor, dual of the inductor is capacitor, and capacitor inductor. And if there is a voltage source, then in the dual, that will be the current source. Suppose in the original network we have the 10 volt, 10 ohm, 2 Henry and 3 farad. Okay, these are the some variables. So in the dual of the voltage source will be current source, and the magnitude of that current source will be the 10 ampere. Okay, the magnitude will be same, only we take the unit of the dual. That will explain later on with the help of some examples. Then the most important thing is how we orient the source in a dual network. So what we do, we assume a clockwise direction for all the mesh currents in the original network, say N1. So we have a network N1, then we identify the meshes, then we orient all the meshes in the clockwise direction. All the meshes in clockwise direction. We cannot do, we orient one mesh as a clockwise, another one as anti-clockwise, we can't do in that fashion. Then the orientation of the voltage source is identified by the direction of the mesh current. If the direction of the mesh current and the voltage polarity is same, then the orientation of the current source in the dual network will be towards node. Node means there are two types of node, main nodes and reference node. So towards node or away from node, that is with respect to the main node. We have nothing to do with the reference node. We have only consider the main node. However, if the direction of the voltage source, that is the polarity of the voltage source, and clockwise direction of the mesh current opposing each other, then the current source in the dual network will be directed away from the node, that is the main node. So very important to just, node means main node. Suppose we just try to explain the procedures with the help of some examples. Here we can see that there are two independent loops. So, two mesh, say these meshes are oriented in clockwise direction, we can see here. Then what we do, we just mark mesh 1 and mesh 2, okay, and outside this we can have a reference node, okay. So, connect element between these two nodes traversing one element at a time. So, from 1 and reference we can do in this fashion, then 1 and reference we can do in this fashion, then 1 and 2 is and this, traversing one element at a time, and this is, okay. So, how many meshes are there in the original network? There are 2. So, in the dual network there will be 2 nodes. So, say this is your 1 and this is, so say this is your 1 and this is a 1 2 node 2, and outside this we have the reference node, okay. From node 1 to reference node, that is this, that is your datum node, or you can say the reference node. One voltage source. So, in the dual network, this, the dual of the voltage source is the current source, and we can see here the orientation, the orientation of this mesh current is clockwise, and it is supporting the polarity of voltage source. That is, it is entering the negative terminal and leaving the positive terminal. So, this current, mesh current, is supporting the polarity of this 10 volt voltage source. So, this current source in the dual network will be towards node of magnitude 10 ampere. So, towards node means this node, Look at here, from 1 to reference there is a 5 Henry. So, 5 Henry, so we have the 5 farad. In dual of the inductor is a capacitor, so it is 5 farad. Now, come to here, between node 1 and 2 there is a 2 more conductance. So, between 1 and 2 there will be a 2 ohm resistor, okay. We take the magnitude, same magnitude from the original network, only unit will be the of the dual network. Now, come to 2 and reference, we have the 5 farad. So, we have the 5 Henry here, 5 Henry. And then from 2 to reference node we have 1 ohm resistor. So, we can have 1 more. So, this is the dual of the network. Two independent loops, 2 nodes, 10 volt sources, 10 volt voltage source will be a 10 ampere current source, 2 more 2 ohm, okay, and 5 Henry 5 farad. So, this is the dual of the network. So, this way we can draw the dual. Look at some more complex here. We can see here. So, here we have taken a voltage source in second. So, there are 2 independent loops. So, mark them 1 and 2, and we have orient the 2 meshes in clockwise direction, and we have taken the 1 reference node outside. So, traverse one element at a time. This much you can do. Now, the difference is how we will orient this 6 volt voltage source, okay. So, look at here, there are 2 meshes, so 2 nodes. This is say node 1 and this is node 2, okay. And then we have taken the reference node here. Between 1 and reference we have the 12 ampere current source. So, in the dual it will be a voltage source of 12 volt. Okay, magnitude will be the same, only the unit will be of dual. So how will orient this voltage source? What should be the where should the plus polarity and where will be the minus polarity? So look at here, this mesh current I1 is supporting the 12 ampere current source. It means the plus terminal of this voltage source will be towards node 1 and the minus will be reference node. Now come to the this. So this is will be 4 farad capacitor. In between 1 and 2 there is 6 farad capacitor. So we have the 6 Henry inductor. Between 1 and reference we have the 0.1 ohm resistor. So we have 0.1 mho conductance. And look at here. So most of the time students commit mistake here. We can see here that the mesh current of this this loop is supporting the voltage polarity of this voltage source. So the direction of the current source will be towards node. We have just written in the procedure. So towards node means which node? Main node. So main node is 2. So it will be like 2. 6 ampere. So most of the time students commit mistakes. So they are saying that it is supporting, so it will be towards node means this reference node. We have nothing to do with the reference node. The node means the main nodes. Okay, so this is the dual of the network. Now we are moving from simplest to simpler than the complex one. So here we can see that again there are 2 independent loops. So 2 meshes, mesh 1 and mesh 2. Take the reference node, traverse one element at a time, this way, then this way, then this way, then we can have this way. Okay. Now in the dual network there will be 2 nodes. So say node 1, this is node 1 and this is node 2. 2 nodes. So between 1 and reference node we have the 2 ohm resistor. So first we draw this voltage source. So this mesh current is supporting the direction of this source current 4 ampere. So in the dual network it will be a 4 volt voltage source, and since the direction of the mesh current is supporting the direction of the source current, so it will be here will be the plus and here will be the minus. Then from 1 and reference we have the 2 mho. So we can draw this 2 mho. Then we have the inductor. Inductor means we can have the capacitor of 4 farad. Remember, magnitude will be same when only the unit will be of dual network. Look at here, this is very important. This 2 Henry and 5 volt voltage source, they are connected in series. So if we remember the procedure in the dual network, these 2 elements means 2 farad and 5 ampere current source, they will be in the parallel and they will be in between node 1 and 2. This much we have studied from the graphical procedure. So, come here, 2 Henry, so 2 farad, then we have a current source. I will define the direction of this current source. What should be? It should be from 1 to 2 or from 2 to 1. How it will be? Let us decide here. Suppose this is current is I1. This is I1 and say this is I2. So I1 minus I2 is entering plus terminal, meant it is opposing the, if I1 is greater than I2, so it is entering the plus terminal and leaving the minus terminal. It means I1 minus I2 is opposing the polarity of the voltage source. So in the dual network, the current source will be away from node. So now question is which node? Node 1 or node 2? I1 is governed by this mesh 1. So it will be away from the node 1. So this will be like this. And it is of 5 ampere. Other may say that I2 is greater than I1. There may be another possibility, I2 may be greater than I1. So I2 minus I1 will be entering the negative terminal and leaving the positive terminal. It means I2 minus I1 is supporting the voltage polarity. So when the I2 minus I1 is supporting the voltage polarity, so in the dual network, the direction of current source will be towards node. So which node? Node 2, because node 2 has the I2. So it is 2. So this way we can, now remaining we can draw here. So here we have the 1 ohm resistor, so it is 1 mho. 1 mho, then 3 ampere. Look at the 3 ampere. So 3 ampere current source is, the I2 is supporting the direction of 3 ampere current source. So the voltage source of this 3 volt will have positive terminal towards node 2 and the negative reference node. So this way we can draw the dual of the network. Only problem you may face when there is source, just to orient the source. There we can, okay, we can draw the dual of the network. No problem, simple, we can do it. Now, how will check whether the given network is, we have drawn the dual network correctly or not? How will check it? So look at, I have taken a very simple resistive network containing 2, 4 and 5 ohm resistors and 2 energy sources. One is the current source of 2 ampere and other one is the voltage source of 4 volt. So from here, suppose I can find the I1 and I2, which is here in case of 2 ampere, okay, and we can find the I2 by applying the Kirchhoff's voltage law in this loop. And first we draw the dual. Look at here. So this is supporting. So this is the 2 volt voltage source. Then we have half ohm. We can say the 2 mho. So 2 mho can be written as half mho. Then it is, all are written in the impedances 1 by 5. It is basically 4 mho, so 1 by 4 ohm, and 5 mho, so 1 by 5 ohm and 4 amperes. I have taken, this is the dual of the network. My question is whether we have drawn this dual network correctly or not. How will check it? So come here, find the value of I1, which is 2 ampere. Now apply the Kirchhoff's voltage law in this loop. Say this is A, B, C and A. So from A to B we are moving against the direction of current. I1 minus I2 will be from B to A, and we are moving from A to B. So 4 I1 minus I2, this is the impedance across this. Then we are moving from B to C. So we are moving the direction of current. When the observer is moving the direction of current, he or she will experience a potential drop. So it is minus 5 I2. Then we are moving from minus to plus, so 4. So on simplification we can have the I2 is equal to 4 by 3 ampere. Okay. So from the original network, applying the Kirchhoff's voltage law, we have find the I1 and I2. Okay. In the dual network, I1 corresponds to V1 and I2 corresponds to V2. So I1 should be 2 volt and I2 should be 4 by 3 volt. Okay. Now check here. So we can see here V1 is 2 volt. Straight we can write 2 volt. Now apply KCL. Apply KCL at V2. So we can write here 4 V2 minus V1, sorry, V1. This is away, this is V2 minus V1 will be like this, okay, plus 5 V2 away equal to 4. So on simplification we can have this 4 by 3. V1 is 2, KCL at node B, we have written this KCL equations. From here we can on simplification put the value of V1, that is 2. So 4 into 2, so minus 8. So here it will be 12, and the 4 V2 plus 5 V2, that is the 9 V2. So 12 by 9, that is 4 by 3. So this is 4 by 3. Okay. So this way we can check whether we have drawn the dual network correctly or not. This is the procedure. Now come to the limitations. So there is no dual relationship for network having mutual inductances. So if the network containing mutual inductances, we cannot apply the duality. Then dual can be drawn for planar network. In case of the network must be planar. In case of the graph theory, the graph must be planar graph. So what is the definition of planar graph? A graph is said to be planar if you draw the graph on a sheet of paper in such a way that no two branches cross each other. If there is crossing of the branches, then that graph is the non-planar. So these are some limitations of duality. We cannot draw the dual of network having the mutual inductances. The network must be planar and graph must be the planar graph. So this is all about your duality. The most important thing is how you are going to orient the source in a dual network. That you have to remember. If you find any difficulty, you can write mail to me. So thank you very much. Jai Hind.